This is Alex with WMD, and today I'm going to demonstrate some of the features of the Geiger counter Eurorack module. The Geiger counter is a wavetable distortion as well as a bit depth and sample rate reducer. For this video, we are going to focus on the bit depth, sample rate, and wavetable knobs and CV inputs. We'll only be using the direct input, which ignores the gain and tone circuits. The reason we are doing this is to give a more accurate representation of the wavetables and affected waveforms, how they sound, and what they look like on the O-Tool oscilloscope module. Looking at the O-Tool, the green waveform is our clean, unaffected saw wave coming from the phase displacement oscillator, and the red waveform is the output of the Geiger counter. As you can see, we have the Geiger counter's wavetable set to number 20, which is a sine wave. The wavetable function of the Geiger counter takes your incoming signal and remaps it to a shape determined by a table of voltages. With a saw wave as the input, the signal can be accurately changed to a sine wave through the entire length of the wave. There is a complete list with graphical representations of each wavetable on our site at wmdevices.com. Now, watch the O-Tool and listen as we reduce the bit depth knob. The signal is converted from analog to an 8-bit digital signal, and its bit depth is halved incrementally all the way down to 1 bit, where we see and hear a square wave. Bit depth chops the signal vertically and reduces resolution of the waveform by restricting the voltages to steps, making the waveform more and more square-like and distorted sounding. The sample rate knob is similar to bit rate, but it holds more of the waveform shape as it controls the length of the samples your signal is being converted to. Sample rate affects the waveform over time, meaning the signal is chopped laterally, and resolution is reduced by lengthening the samples no matter how many bits the waveform is conforming to. When this knob is at the highest setting, the sample rate is faster than CD quality and passes signal virtually unaffected. Bringing the sample rate down lengthens the samples, creating a nasty lo-fi sound. Both of these knobs can be controlled with CV, and their CV level knobs attenuate the amount of modulation that can occur from your CV source. The bit depth knob becomes an offset for CV when the jack is filled. And now, sample rate. Just like the bit depth, the sample rate knob now becomes an offset for CV, and the CV level knob attenuates how sensitive the input is to control voltage. The wavetable knob steps through different waveforms that the Geiger runs your signal through, and can also be controlled with CV. My favorite way to step through the waveforms is with a sequencer as the source. Here's what that sounds like. Use the wavetable CV level knob to again attenuate how sensitive the input will be to CV, and adjusting the wavetable knob will change the center waveform in which we are modulating around. Unplug the jack, and the Geiger will revert to the wavetable last set as center. Now, I'll quickly sweep through the wavetables. Keep in mind, there are over 200 of them, so I won't stay long on each, and I won't get to all of them either. Again, there is a list of all the wavetables with graphics for each one on our site. Now, let's check out how the Geiger counter reacts when we run a drum sequence through it, and then use the CV inputs for some extra wackiness. This is the dry signal of the drums alone. And now I'm mixing in the dirty signal from the Geiger. Having a nice mix between the two keeps the drums punchy and clear, while the distortion adds great texture and more fun. And now, let's hear the Geiger make us a bass line. I'm running a sine wave into the direct input of the Geiger and then going straight into the audio recorder. I'm using the sequential switch matrix's DAC output to control the wavetable CV input with control voltage, as well as to trigger a kick drum and hi-hat via the SSM expand for the dancey feel. The SSM expand is also sending two trigger signals via separate outputs. One at the beginning of each bar to a multi-mode envelope which is modulating the sample rate CV. The other trigger out is triggering another envelope on count 3 of each bar and modulating the bit depth CV in. I have the SSM stepping at 16th notes, making for a 1-bar pattern of an almost glitchy rhythmic bass line. We are clocking the SSM with the Pro Modular clock as our master clock. Pushing the wavetable knob like a button changes sample rate range and bit depth mask modes. This drastically changes how the wavetable affects the signal. As for the sample rate LEDs, when the sample rate LED is red, the sample rate is in fine mode, where the range is limited to the upper end of sample rates, and adjustments to the sample rate knob are much more subtle. When the LED is green, the sample rate knob is logically ANDed or added to the CV signal. This can produce some interesting sounds as the CV changes. When the bit depth LED is green, the Geiger counter will enter bit depth mask mode, where your signal is logically ANDed to the 8-bit number produced by the bit depth knob. This produces uneven gaps in your signal and can create some interesting distortion sounds. When the bit depth LED is red, the Geiger will switch the order in which your signal hits the wavetable. With the LED off, your signal hits the wavetable before reaching the bit depth knob's destruction of the wave as it is quantizing the output. When the LED is red, however, your signal's bit depth gets reduced before going into the wavetable, meaning that the bit depth knob will change how the wavetable reacts with your signal. When using both modes at once, the sample rate and bit depth knobs will be orange. You can cycle through every combination of green and red by continuing to push the wavetable knob. For this patch, we are using the Geiger counter as a source of inspiration as it is determining the melody you are hearing. We've got a slow, inaudible saw wave LFO going into the direct input of the Geiger counter, and the output is feeding into a quantizer and then into the 1 volt per octave inputs of both an oscillator and a filter. The trigger out of the quantizer is opening our VCA each time the note is changed. As you can hear, the oscillator's pitch is following the waveform being produced by the Geiger counter's wavetable. With a simple switch from the major to minor modes on the quantizer, we get a rather interesting melody. The Geiger counter is useful for a handful of artists, especially sound designers looking to make new tones. For this patch, we are running a signal from an oscillator into a VCA being opened and closed by an envelope with a fast attack and a very slow release. Listen to the way the Geiger reacts to the decay of the amplitude in the signal, almost sounding like a resonant filter. Experiment by sending the envelope and other signals into different CV inputs of the Geiger. The possible outcomes are truly endless. Here I'm molting the envelope into the sample rate input for more depth in the distortion sound. And now we're molting the envelope into the wavetable CV-in to create even more details in the decay.